60 hours. Somewhere between 13 and 15 cubic kilometers of magma driven out of the ground and thrown into the sky. An ash column that punched past the top of the troposphere in under an hour and kept climbing to roughly 30 kilometers, 3 times the height of Everest. Enough fine material in the stratosphere to dim the sun across the entire northern half of the planet and hold it dimmed for 2 years. It was the most powerful volcanic eruption of the 20th century. Not the deadliest, the most powerful. Bigger than Mount St. Helens by an order of magnitude. Bigger than Pinatubo. Bigger than Krakatoa. And if you stopped 100 people on any street in the world and asked them to name it, you would very likely get 100 blank looks. There is a second thing about it that is stranger still, and it is the reason I wanted to make this film. For 41 years, every textbook on Earth named the mountain responsible. Every encyclopedia, every geology course, and every one of them was wrong. The mountain they blamed never erupted at all. It was, in the most literal sense available to geology, a victim, hollowed out from below by something 10 kilometers away that nobody had bothered to put on a map, because on the morning it happened, that something did not yet exist. Set it against the eruptions we do remember, because the comparison is what makes the silence so strange. Krakatoa, 1883. Roughly 12 cubic kilometers of material, around 36,000 dead. The sound heard thousands of kilometers away. The world has never stopped talking about it. Tambora, 1815. Larger again, the eruption that stole a summer from the northern hemisphere and put famine into Europe and North America the following year. It is in the history books, the climate records, the literature. Vesuvius in the year 79. Small by comparison in pure volume, but it sealed a Roman city in ash with the people still inside it, and 2,000 years later, we are still carefully brushing them free. Now Alaska, June 1912. Larger than Krakatoa, many times the erupted volume of Vesuvius, a genuine planetary event recorded on instruments across 3 continents, and the world remembers essentially nothing. So the questions I kept circling are these. How does an event on that scale disappear inside a single human lifetime? How does science name the wrong mountain, keep naming it for 4 decades, and never quite get the correction into the books ordinary people read? And who decides, because somebody, somehow, does decide, which catastrophes we carry with us and which ones dissolve into a footnote? By the end of this, 3 things will be clear. Why several hundred people on Kodiak Island spent 2.5 days in a darkness so complete they were certain the world was ending. Why a botanist with no training in volcanology walked over a ridge in 1916 and found a landscape that had no business existing anywhere on this planet. And why one young geologist in a single field season in 1953 quietly demolished everything 2 generations had been taught about what happened in Alaska in June of 1912. Start with a man who could not see. On the afternoon of the 6th of June, 1912, on the coast of the Alaska Peninsula near a place called Kaflia Bay, a fisherman named Ivan Orlov was less than 50 kilometers from a vent that was about to become the loudest thing on the planet. He had no radio. There was no instrument within 100 kilometers. There was no warning of any kind, because there was no one to give one and nothing to give it about. The ground he was near had no name and no history of erupting. What he had was sound, a low, continuous roar that he would later describe as worse than any storm he had known in a lifetime of working that coast. Then the sky to the west went the color of wet iron. Then ash began to fall, not drifting like dust, but coming down heavy and wet like snow. Within hours, he could not see his own hand held out in front of his face. Orlov did what people do when they are certain they are about to die, and there is nothing else left to do. He wrote to his wife. He described a mountain throwing fire, a noise that would not stop, a darkness that had swallowed the world, and his belief that he would not survive it. Then he sat in the dark with the letter. He did survive. The letter survived with him, and it was published more than a year later, and it remains one of the very few first-hand written accounts from anyone who was inside the ash zone while it was happening. That is worth sitting with for a second. The largest eruption of the century and the human record of its opening hours comes down to a handful of pages written by a frightened man who assumed no one would ever read them. 160 kilometers east, across open water, the town of Kodiak had several hundred residents, a Russian Orthodox church, and the United States revenue cutter Manning at anchor in its harbor under Captain Perry. Kodiak was far enough away to be safe from the eruption itself. It was not far enough to be safe from what the eruption put into the air. On the 7th of June, the sky over Kodiak began to darken around midday. By 3 in the afternoon, the sun was gone. By 6, every lamp in town was lit. And then it kept getting darker, which is the part that breaks people, because darkness at midday is strange. But darkness that deepens hour after hour with no explanation reads to the human nervous system as the end of the world. By midnight, the ash was falling at roughly a centimeter an hour. Roofs began to groan under the load, and some of them gave way. Breathing outdoors required a wet cloth held over the face. Walking 100 meters from your own door filled your boots. And for 2.5 days, Kodiak sat in a dark so total that a lantern held at arm's length simply could not be seen. The temperature fell by several degrees in a month when it should have been climbing. The surface of the harbor stopped behaving like water, not frozen by cold, but loaded with so much floating ash that it went slack and stiff and stopped moving like a sea at all. Captain Perry took the townspeople aboard the Manning, sealed the hatches, and put crew on the upper decks with shovels, working in shifts through the dark, because the ash piling on his own vessel was heavy enough to sink her at anchor. When it finally stopped, 1/2 meter of gray dust lay over the island. Buildings had collapsed. Dead birds and animals lay in the streets. It would take the town the better part of 2 years to dig itself out. And here is the thing that still unsettles me about Kodiak. Not one person there ever saw the eruption. They lived through the largest volcanic event of the century as a sound, and then as a darkness, and never once as a sight. Closer in, there was no story to tell afterwards, because there was no one left to tell it. The settlements nearest the vent, Katmai, Savanoski, Douglas, were abandoned within hours. People took what they could carry and ran for the coast, and the coastal villages took them in, and none of those 3 settlements was ever lived in again. 3 communities erased in a weekend, their populations absorbed elsewhere along the shoreline, their names surviving now mainly as labels on a map for places where nobody lives. Nobody within 50 kilometers of the vent was there to watch what happened. That fact will matter enormously later, in a way that has nothing to do with geology and everything to do with memory. Hold on to it. And there is one more thing about those first hours that nobody witnessed, that nobody reported, and that nobody even suspected for 3 full years. Something the falling ash hid completely, sitting under the surface story like a second story underneath the first. It would take 4 decades to read it properly. The first scientific expedition to reach the eruption zone arrived in the summer of 1915, 3 years late, and it was led, improbably, by a botanist. His name was Robert Fisk Griggs, from Ohio State University, working under the National Geographic Society. He had no formal training in volcanology whatsoever. He had been sent north to answer a botanist's question. How does plant life come back after a landscape is sterilized? And he ended up, over 4 summers and 4 expeditions, producing the foundational survey of the largest eruption in modern history. Each trip overturned the conclusions of the trip before. That is not a criticism. That is what honest field science looks like when nobody has been there before you. In 1916, he climbed Mount Katmai, the obvious suspect. Katmai had been named the source almost by default. It was large, it was in roughly the right place, and there was no other candidate anyone could see. What Griggs found at the top was not a summit. It was an absence, a caldera roughly 3 kilometers by 4 and close to a kilometer deep, with sheer walls and a lake beginning to pool at the bottom in a still, gray-green color that belonged to no ordinary body of water. Steam came from cracks in the caldera wall. The wind across the rim was dry and warm, even late in the season, and the air carried sulfur. More than 360 meters of mountain had gone. The case looked closed. Katmai had blown its own head off, and the missing rock was the ash on Kodiak. Except that Griggs did the arithmetic, and the arithmetic refused to work. Measure the whole. Take the volume of mountain that is now missing from Katmai's summit, calculate it carefully, and you get something in the order of a single cubic kilometer. That is an enormous quantity of rock. It is also nowhere near enough. Now measure the deposits. The ash on Kodiak, the fall across the peninsula, the layers on the sea floor, the dust logged across 3 continents. Add it up, and you are somewhere around 15 cubic kilometers of material. The 2 numbers are not close. They are not within argument of each other. They differ by a factor of around 15, and no reasonable error bar closes a gap like that. So in 1919, Griggs published the question plainly. If Katmai's summit only accounts for 1 cubic kilometer, where did the other 14 come from? The paper was read, the question was noted, and then it was quietly set on a shelf, where it stayed for 34 years, while the textbooks went on printing the name Katmai and treating the volume discrepancy as somebody's sloppy measurement. I find that gap, 34 years between a good question and anyone taking it seriously, more interesting than the geology. Science did not fail to notice. It noticed, shrugged, and moved on, because the alternative explanation had not been invented yet. Because in between, Griggs found something that took all the attention. In 1916, crossing a ridge west of Katmai, he came over the top and stopped. Below him lay a valley more than 20 kilometers long and several kilometers wide, and it had been filled, completely filled, with a smooth, flat, featureless gray deposit, hundreds of meters thick. Where a valley floor with a river and trees should have been, there was a level plain the color of cement, and the plain was steaming. Not in one place, everywhere. Jets of steam rising from fissures across the entire surface, from one end of the valley to the other, thousands of them, tens of thousands. The air over the whole basin shimmered with heat. The ground was hot through the soles of his boots. He called it the Valley of 10,000 Smokes, and the name stuck, and the name was an undercount. Later surveys put the number of active fumaroles at the time of discovery closer to 100,000. Some vents measured in the region of 645 degrees Celsius, hot enough to melt lead, hot enough to work iron with no forge. Water tipped from a flask boiled on the rock where it landed. What Griggs was standing on was neither lava nor ash. It was the cooled body of a pyroclastic flow, a ground-hugging avalanche of superheated gas, pumice, and shattered rock that had come down that valley in the first hours of the eruption, at speeds no living thing could outrun, and buried the original landscape under as much as 200 meters of itself. It covered more than 120 square kilometers. Everything underneath it, soil, plants, animals, the river, the shape of the ground, was gone. Not damaged, replaced, and nobody saw it. It happened in the first 3 hours, under a sky already black with falling ash, in a valley where nothing lived. It killed no one, because there was no one to kill. By the time daylight returned to Kodiak, it had already cooled into stone, and not a single human being on Earth knew it had happened. That is the second story that was hiding under the first one. An event the size of a city, invisible for 3 years, discovered by a botanist who had come to look at plants. Griggs and his team photographed the valley obsessively across 4 seasons. Several thousand glass plates, showing steam columns hundreds of meters tall, and men standing on a plain that looks, in the images, like the surface of another world. Most of those plates went back to Washington, were cataloged, and have never been published. Now the part that makes this a detective story, rather than a survey. 10 kilometers west of Katmai's empty summit, on the floor of that same valley, there is a small dome of lava. It is about 400 meters across and about 60 meters high. Against a landscape of Alaskan peaks, it registers as a blemish, a low gray lump on a flat plain. Early expedition maps did not always bother to mark it as a feature at all. Griggs walked past it. He noted it, in passing, as an inactive vent, and he gave it a name almost as an afterthought, Novarupta, from the Latin for newly erupted. And then he moved on, because he had a valley of 100,000 steam jets to survey and a caldera the size of a city to measure. And nobody looks at a 60-meter bump when there is a kilometer-deep hole on the horizon. He was standing on the answer. He named it. He wrote it down. And then he walked away from it. And so did everyone else for the next 34 years. Because in 1919, there was no instrument on Earth that could have proved him wrong. The geochemistry did not exist. The mapping techniques did not exist. The question simply could not be answered yet, so it waited. In 1953, a young geologist named Garnis Curtis, working out of Berkeley, went into the Valley of 10,000 Smokes. By then, the smokes were mostly gone. The deposit had cooled. The fumaroles had died back. And for the first time, the valley was a place where careful, unhurried fieldwork was actually possible. Curtis was not hunting a controversy. He was collecting samples. He spent the season gathering pumice, ash, and lava from across the deposit zone, mapping thicknesses, recording where each material sat and how much of it there was. The pumice he was handling was so light that a fist-sized piece floated, and so sharp along its broken edges that it opened the skin on a bare hand. Then he took it back to the laboratory, and the samples started saying something impossible. The pumice from the eruption was not one rock, it was 3. Curtis identified rhyolite, pale, gas-rich, the most explosive kind, so full of bubbles it is closer to a foam than a stone. He identified dacite, a step darker and denser, and he identified andesite, denser again and least explosive, the ordinary workhorse rock of subduction zone volcanoes. All three of them lay in deposits laid down inside the same 60-hour window. All three had come out of the same opening at essentially the same time. And by every model of how volcanoes worked in 1953, that should not have been possible. A single magma chamber gives you a single dominant chemistry. Three distinct chemistries in one eruption meant the magma had not come from one place. It had come from at least two. Then Curtis did the simple, decisive thing that nobody had done properly in 41 years. He mapped the deposits by geometry. If you measure how thick the pumice layer is at many points and plot how that thickness falls off with distance, the pattern radiates outward from the source, like ripples from a stone. Thickest at the vent, thinning steadily outward. You do not need to guess where an eruption came from. You can read it off the ground if you take enough measurements and are willing to trust them over the textbook. Curtis measured, plotted, and overlaid the patterns, and the answer came back with no ambiguity in it at all. The center of the eruption was not Mount Katmai. The center was 10 kilometers west. The center was the little gray dome that Griggs had strolled past in 1916 and written off as inactive. The center was Novarupta, a name that by then had been forgotten by more or less everybody, except the United States Geological Survey, which had kept it filed away in one of the more obscure entries in its catalog. Curtis published in 1954 and brought the name back from the dead, which leaves the obvious problem. If Novarupta erupted, why is Katmai the one with a kilometer-deep hole where its summit used to be? The answer is the most remarkable thing in this entire story, and it is the reason I think this eruption deserves to be famous. Katmai's summit did collapse. That part was never wrong. But it did not collapse because Katmai exploded. It collapsed because Katmai was empty. The magma chamber beneath Katmai drained sideways through a lateral conduit running roughly 10 kilometers underground and came up at Novarupta and erupted there. The chamber under Katmai was pumped hollow over the course of about 60 hours. And when a mountain's foundation is removed from underneath it, the roof of the empty chamber fails, and the summit goes down into the space where its own magma used to be. Katmai did not blow up. Katmai fell in. Geologists call this magma piracy. One volcano stealing the contents of another's chamber, so that the mountain that gets destroyed is not the mountain that erupts. It is genuinely rare. There are only a handful of documented cases anywhere in the world. Novarupta is the largest example known in human history, so sit with the shape of the mistake. For 41 years, science named the wrong mountain, and it named it for an entirely understandable reason. Katmai looked guilty. It had the crater. It had the missing summit. It had every visible mark of a volcano that had detonated. The real culprit was a 60-meter lump on a valley floor that most maps did not bother to draw. The evidence had been visible the whole time, a hole that was too small by a factor of 15, and everyone had looked at it, and everyone had assumed the measurement was wrong rather than the mountain. That explains the science. It does not explain the silence, and the silence is the part I find harder to shake. 1912 was a crowded year. The Titanic had gone down in April and was still consuming the world's attention. The Mexican Revolution was grinding through its second year. In the Balkans, the arrangements that would produce a world war were quietly assembling. Against all that, an eruption in an almost empty corner of southwestern Alaska, in a place most Americans could not have found on a map, with no reported death toll, had very little chance. The first headlines about ash on Kodiak ran in late June. By July, the Russian Orthodox Church in San Francisco was organizing relief for displaced Alutiiq villagers. By August, the story had slid to the inner pages. By September, it was out of the papers altogether. And then, 2 summers later, Europe went to war, and the entire world's attention was spoken for the next 4 years. The catastrophe left the news and left human memory in almost the same season. But underneath the timing, there is a colder reason, and it is the one that generalizes. Krakatoa killed tens of thousands. Tambora killed on a scale that reordered the food supply of the Northern Hemisphere. Vesuvius sealed a city with its citizens inside. Each of those events had what Novarupta did not: a body count, an audience, and survivors who carried the story into the culture and kept telling it. Novarupta had almost none of that. The villages nearest the vent got out in time. The displaced people were absorbed into settlements down the coast. The deaths that certainly followed, from disease, exposure, hunger, dislocation, the ordinary slow killers that come after any disaster, were never gathered up and counted as eruption casualties. So the official figure in most reference books remains 0. And a catastrophe with no body count is something our memory machinery simply refuses to process. It has no faces. It has no funerals. It has nothing for a newspaper to photograph. It ranks, in the end, below far smaller events that happened to occur where people were standing, which is a strange verdict to reach about an event whose fingerprints were global. Wes Hildreth, the USGS volcanologist who has spent much of his professional life on this system, and colleagues after him, have traced that signature in detail. Fine ash was detected as far away as North Africa. The acoustic pressure wave from the eruption registered on barographs more than 2,000 kilometers from the source. Across Europe and North America, sunsets turned an abnormal red for months afterwards, recorded in newspapers, in photographs, in paintings, while nobody making those records had the least idea they were looking at Alaska. And the climate moved. The sulfur that Novarupta put into the stratosphere measurably cooled the Northern Hemisphere through the following year, a fraction of a degree on the average, which sounds trivial and is not, because averages are made of growing seasons. Cold summers and poor harvests followed across parts of Europe and Canada. The eruption reached into the food supply of the northern half of the world, and no one connected the two. 13 to 15 cubic kilometers of magma, more than the next several largest eruptions of the 20th century put together. A 6 on the Volcanic Explosivity Index. The closest modern comparison is Pinatubo in 1991, which produced something like a third of the material, killed several hundred people, and is remembered by everyone who was alive for it, because Pinatubo happened in front of cameras in a populated country with an evacuation and a news cycle and a film crew. That is the uncomfortable conclusion, and I think it is the real subject of this film. The memory of a catastrophe scales with the size of its audience, not the size of the event. A larger disaster with no witnesses dies in the archive. A smaller one with cameras present enters the canon and stays there, which cuts in 2 directions at once. It means there are almost certainly other Novaruptas in the geological record, events of this scale or larger that we do not know about, not because the evidence is missing, but because nobody was there to be impressed. And it means the next one gets remembered or forgotten according to where it happens, not how big it is. The Alaska Peninsula is one of the most volcanically active places on the planet, more than 50 active volcanoes, and on average, something significant erupting every couple of years. Almost all of it is small. Nothing since has come near 1912. Nothing yet. the monitoring is unrecognizably better than it was. The Alaska Volcano Observatory runs seismometers, gas sensors, ground deformation arrays, and satellite thermal imaging across the region. And the magma chamber under Katmai, the one that was pumped hollow through 10 kilometers of conduit in 1912, is slowly refilling. The rate is slow. The seismicity is quiet. There is no sign that anything is imminent. There is also no guarantee that the warning, when it comes, would be enough. Novarupta produced almost no precursor. The first significant earthquakes were recorded in early June 1912. The eruption began about 5 days later. With today's instruments, 5 days would certainly buy a regional alert. It would not buy a full evacuation of the peninsula. And the pyroclastic flow that filled that valley in 3 hours cannot be outrun by anything moving on the ground. The valley itself is protected now. The core of Katmai National Park, made a national monument by President Wilson in 1918, largely on the strength of Griggs's expeditions. The smokes have almost entirely gone. The 100,000 fumaroles are down to a scattering of vents near the dome. The valley is cooling, and within another generation or two, the name may simply stop being accurate. Stand on the rim of the Katmai caldera on a clear Alaskan night, and the thing that strikes you is the silence. The lake at the bottom is black and completely still. The wind moves along the rim without hurrying. 10 kilometers west, if the light is right, you can just make out Novarupta, a small gray lump on a wide, empty plain, so unremarkable that you would need someone to point it out. There is nothing in that view that tells you what happened underneath it in 1912. There is nothing in it that tells you what may happen underneath it again. And that, I think, is the lesson underneath the geology. Geological time does not care whether anybody is watching. An event can drain a mountain from below, erase 3 villages, bury a valley the size of a city, cool an entire hemisphere, and change the color of the sky over 2 continents. And if it happens somewhere empty enough, the official record will read no fatalities, and the whole thing will settle into a footnote. The footnote becomes a citation. The citation becomes a paragraph in a book nobody opens. And the forgetting is complete inside 1 human lifetime. Eruptions of this magnitude come around, somewhere on Earth, roughly once a century. The last was Pinatubo. The one before that was Novarupta. So the question was never whether there will be another one. There will. The question is where, and whether it happens in front of cameras and instruments and witnesses, the way Pinatubo did, or somewhere empty enough to be forgotten again. For 41 years, we blamed the wrong mountain for this one, and the right one sat there the whole time, 60 meters high, unmarked on the map, waiting for somebody to measure carefully enough to notice. That is not really a story about volcanoes. It is a story about how thin the record is, and how much of what has happened to this planet is sitting somewhere in plain sight, correctly filed and simply not yet read.